Hello everyone! This week we are going to talk about what it takes to reach interstellar space. We currently have 5 probes heading out of the solar system, and some space junk as well. To accomplish this, the probe needs to reach the sun's escape velocity, which is 42.1 km per second. To put this in perspective, normally when a mission ends, the probe keeps orbiting the planet, crashes into it, or if it was a flyby mission, it goes into an heliocentric orbit because it's still bound to the sun's gravitational attraction. The 5 probes setting out were missions to study the other planets, so thanks to the velocity they reached after launch, plus some gravity assists, they managed to reach escape velocity. Those missions are Pioneer 10 and 11, which flew by Jupiter and Saturn, Voyager 1 and 2, which flew by Jupiter, Saturn, Uranus and Neptune, and finally New Horizons that flew by Pluto. I mentioned space junk earlier because New Horizons was launched directly into a solar escape velocity, and because of this, the third stage, a Star 48 solid fuel booster, is heading out to interstellar space. New Horizons also used yo-yo the spin weights on wires to reduce the spin of the spacecraft. Those weights and wires were released after use, so they are now on an escape trajectory as well. We have no way to track such objects, so we cannot know their exact location. Interstellar space is not an arbitrary definition, and it also doesn't mean that you left the solar system. So what is interstellar space and how do we know that we got there? Interstellar space is the matter that exists between star systems. The heliosphere separates our solar system from the interstellar medium. This is formed with a solar wind that creates a bubble that reaches far beyond the Kuiper belt. Voyager 1 is the only probe so far that crossed this region. It was difficult to confirm because the solar wind detector ceased functioning in 1990. Nevertheless, it's believed that Voyager 1 entered the termination shock in 2003. This is the point in the heliosphere where the solar winds slow down to subsonic speeds due to interaction with the interstellar medium. Beyond the termination shock, we find the helios sheath, which is the region where the solar wind is slowed down even further, creating turbulence due to compression. NASA stated that Voyager 1 reached this region in 2006. Then we have the heliopause, which is considered the boundary of the heliosphere. Here, solar wind is stopped by the interstellar medium. There are several ways to detect that you cross the heliopause, like a severe drop in the temperature of the charged particles, change in the direction of the magnetic field, and the increase of galactic cosmic rays. In June 2012, Voyager 1 was detecting these changes, except the change in the magnetic field. Finally, NASA announced in September 2013 that Voyager 1 was in fact in interstellar space. At this point, a great number of scientists had dropped the hypothesis of changing the magnetic field when crossing the heliopause. Although it's not correct to say that the probe left the solar system, because our system is defined by the large amount of bodies that orbit the Sun, and Voyager 1 has yet to cross Cygnes aphelion and reach the Oort cloud. Voyager 1 is the farthest probe from the Sun. It's followed by Pioneer 10, and it's expected that Voyager 2 will overtake Pioneer 10 sometime in 2021. They are followed by Pioneer 11. So, New Horizons remains as the closest probe to our Sun, but it's likely for it to overtake the Pioneer probes. It will take a lot of time though. It's not expected to overtake Pioneer 11 before 2082 and Pioneer 10 before 2130, and it will probably never overtake the Voyagers. Well, I hope you liked this episode. If so, please like and subscribe, and have a nice week.